As I discussed here, we should have a big private data. So we do not have a big private data. So what I did, I took the entire paper, this entire paper, as our initial toy big data, like a toy type of big data. And after that, there are multiple ways to generate the triplets, knowledge graph triplets. So one way is directly use your chat GPT. So I had used my chat GPT personalized version directly, and then we uploaded this paper and say that prepare a knowledge graph triplets for this paper. So this is one way. You can see that they have identified the complete knowledge graph triplets for this paper, like graph RAG outperforms naive RAG baseline graph RAG. So you can see that graph RAG is an entity implemented using Python based software. Graph RAG forthcoming AI, so it says like where it is there. Graph RAG uses the Leiden community detection algorithm. So Leiden community detection algorithm actually identifies the community by using the similar type of nodes. So LLM extracts the entity knowledge graph. So similar way it identified all the entities. There is another way also. Before going to this implementation phase, I will explain some basic things. Like for the entire implementations, I have used the Olama package. You can download the Olama from this website. I have used the window-based version. So I downloaded and installed it. Once you install, you can download their models. Models are available here. So I have used the Llama 3 8 billion token, 8 billion parameters based model to run to actually once you install the Olama, it will create a complete directory structure to install everything in your system. So after that, you just need to run this command in a command prompt under this Windows System 32 directory. Then it will directly download the model inside the directory structure formed by the Olama package. So in the model directory structure, it will install that. And after that, we have another thing that is important, like a language embedding part. So in the earlier tutorial, I had already explained like we generally when we use the large language models, for example, suppose we write something like word and then one, then all large language models generally stores all those things in the form of some embedding vectors like that. And for this part, there will be some vector like that. For that, we are using MXPI embedding library. Why we are using that MXBI library? Because as of March 24, this model achieves the SOTA performance for BERT large sized models. So that's why we are using. Installation of this model is again very easy. You have to copy this code and you have to paste it here again in Windows system directory. It will automatically download and install it in your system's embedding directory that is created by Olama package. So once you install everything, you have to install the Chrome DB also. So this is just very simple. Pip install Chrome DB, you can install it. So now the another technique is to construct the knowledge graph by using local language models, large language models that you use locally, that I already explained in the previous tutorials, like how we can develop and construct the knowledge graph triplets. So from here also, just to go and watch the previous tutorials, and then you can easily understand the entire scenario. So based on that, we got for the entire paper that I discussed here, that Microsoft paper, when I run in both places, I got the following entities and entity relation triplets. So when we put those entity relation triplets, it will form a graph. graph type of architecture. Now I'll try to explain that how we can use our graph based RAG pipeline that I discussed here to generate the answers for any query. So suppose this is our documents. I just copied the abstract because it is not possible to copy the entire document. And after that, what we did, we just call the ChromeDB client and then store it in form of doc. And after that, we embed it by using the MXBI embedding large model. And after that, we fire one question. So our question is how graph RAG, retrieval augmented generation, used with large language model generates a global summarization for the given context, like how it generates such kind of things. So you will find that the entire information is not at a one place, it may be at a different places. So what we will do, we will identify the entities. I have just written two entities. There may be multiple entities like graph RAG, large language models, global summarizations, RAG. So all those will be entities. So I left two entities just because for simplicity we are just covering the two important things, but it will not affect the results. So after that we will check the our graph, knowledge graph, that is actually constructed by those triplets. So now if you just start with these two triplets like graph RAG, global summarization and some other entities like large language model, then you will find that in a simple community detection system, or it will extract the triplets like graph RAG uses Leiden community detection algorithm. So from here to here, it will extract all those things. So it contains LLM, entity knowledge graph, graph index, community detection algorithm, graph RAG, global summarization. So most of the entities captured when we create a community by using such kind of triplets. So it will automatically extract the community which contains such kind of things. So we, in the ideal scenario, I am just considering that we have extracted a community which contains those triplets. So we got the community triplets here. Now we have to generate the summary text for these community triplets. So how I generated the summary text? I just use the triplets and then like graph RAG uses Leiden community detection algorithm, and after that I will use that entire triplet as a small text fragments separated by semicolon. So I just concatenated all such triplets like that. And after that the next part is we embed those information like a summary text. We embed those prompt also and summary text also, means we are embedding these questions also and summary text also. Now suppose now the next part is we have to query the part of the text which contains all these useful informations that is useful to answer our question. So for that we query it from the our collections, that is that contains our private text stored in the form of collections after embedding. So from there it will extract the important information in the form of data. So now we have a prompt and data. The data contains the useful information extracted from the private text with the help of knowledge graph based techniques. And then we pass both informations like with by using this context like data, respond to this prompt, means we have to respond to this question, and when we run this we got the very beautiful answer for this question. like it gives everything in the form of step by step, like how we do the pre-processing, how we do the retrieval, how we do the graph augmentations, and how we generate, and how we do the post-processing, and what is the process of global summarization generation. So the final steps involves the combining the summary generated by each node in the graph, like given in the step 4, to form a single global summarization that captures the main idea, themes, and the relations. So this way it actually answered the entire things. So this is one of the way to generate the answer. If you directly pass this question, you will find a very weird kind of simple answer for this question. But after this, I am surprised with this answer. So now, uh, in more detail, if you want to know that how knowledge graph, when we construct it, how it looks like. So here we actually constructed the knowledge graph for all the triplets by using network X, but you can use some Neo4j or some other good packages, then you will get better knowledge graph. So here you can see that for the entire paper how the relations are given. So from there, when you study, then you will identify that which part of the or which subgraph can best suits or answers your questions, and that you have to separate. So as our data is small, so that's why the subgraph is simple. So this is the main thing that I wanted to cover, like what is the graph RAG, how it works, what is the traditional pipeline to cover the graph RAG, why we use graph RAG. So I hope that you will find the entire tutorial very useful and simple. In the next part of the tutorial, I will try to cover like some more advanced strategies to for RAG based methods. So thanks for watching.